Next, we start to apply F equal to ma equation for the rigid body. Okay, as you can see on the screen, when you have an object with the center of gravity or center of mass, you will see the weight is there. Mass converted by center of gravity, acceleration of gravity, you see W. Then you see all the external force. You see the moment, M1, M2, and you see the alpha, this is angular acceleration. Omega is angular velocity, and so on. So you need to convert the free body, this object into free body diagram. By using F equal to mg, by focusing on what happened to the center of gravity. Okay, so when we walk into the rigid body, you don't care what happened to external, you care what is happening to the center of mass, the capital G point. What happened to that? Okay, F equal to mg. So start from chapter 6 onwards, you need to draw two diagrams. One is free body diagram, which is all the external force on one diagram, on free body diagram. Another one is the kinematic diagram. For the kinematic diagram, you draw your A and V, angular acceleration, angular rotation, velocity in another diagram. So you have two diagrams. One is free body diagram, one is kinematic diagram. Then you calculate all the force on the left-hand side. You calculate the acceleration on the right-hand side. Same like what you did in the chapter 2, but this one is on the rigid body. Okay. And you start from F equal to ma in the center of gravity. You can break into x and y direction. Okay, start from here, then you break into x and y direction, meaning all the force that you see on the question, you break into x direction, y direction. The force W always point down, and so on. Next, we will derive the equation of rotational motion. So let's say you have a body on the screen here. You have x-axis, y-axis, interest point is P, and you're referring to one of the point on the body from P, we just label as I. And the location you view from P to the I is R, and it's the external force on this particular section area here. The distance from P to I is X direction. The Y direction is given here. So you know that all these, you have an external force here, the F, you can split into vector and so on. Okay, this is a resultant force, and you can split into, let's say you have three forces, then you can combine this one as a vector diagram and so on. Okay. Capital F is resultant of external force. You combine all the force, you get one resultant. Small fi is resultant of internal force caused by interaction of adjunct particles. For this module, we are not interested in internal force. We are not interested. Okay, unless you go and study material, material science. So we are more interested in these two diagrams. On the left is to calculate all the forces. On the right, we are interested to see the effect of acceleration on the center of mass. Okay, so try to separate the two diagrams, especially the right-hand one is called kinetic diagram. We only interested in the vector for MA. Because the product of M multiplied by acceleration, we get force. Okay, so separate the two diagrams. Then we solve for the unknown. So we do moment, summing the moment about point P. On the left will be R cross Fi plus R cross the internal force I. Moment is always R cross force, R cross F. Right hand side, okay, left hand side is the left hand diagram. Right hand side is right hand diagram. Still calculating moment. So moment is R cross this force. R cross force. But in this case, this is kinetic diagram. Kinetic, you only see mass and acceleration. So you take R cross MA. If you see cross means it's a three-dimensional question or a vector question. On the left-hand side, we derive all the moment at P, all the moment from the point P referring to I. Right-hand side, we continue to copy. Oops. So it just means that at the end, the resultant of everything, the object will rotate, create a moment. So from P to center of gravity, this one I come back to this one later. Too early to explain that diagram. Okay. This one, okay. On the left is this diagram. On the left, capital M is this diagram. On the right is this diagram. So if you look at center of gravity, you have R bar to the center of gravity. And then you have acceleration from P, acceleration from the center of gravity. You have X bar, Y bar, and this object rotates anti-clockwise, acceleration in anti-clockwise, velocity in anti-clockwise. So you will have a moment equal to M multiplied by R cross A and all these things. So this one you learn in your previous chapter, right? So you have AP plus the normal and tangent direction acceleration. This one you learned before this. But again, I won't ask you how to derive this one. At the end, you arrive one equation. Have a long, lengthy, but at the end, you arrive one simple equation. Very lengthy. We simplify. It's quite a long, lengthy derivation, but we're not interested in the derivation. If you're interested, you can go and read during your free time. At the end, we are interested in this equation. The moment at P will be given by this equation. Or in short, you can write the moment inertia in this way. IP equal to IG plus MD square, like what you learned in the first session. I equal to IG plus MD square. D is the distance from the reference point to the G point. This one, how to get X bar, Y bar is this one, this distance. Okay, this distance is a D distance from the G, capital G to the interest point, the reference point. This is a D. So how to find D in this case is Cartesian coordinate X bar square, Y bar square. But again, the highlight still I equal to IG plus MD square. Huh? Okay. I want you to look at one equation, the loss of derivation at the end. A lengthy equation. At the end, we arrive at one equation. Which is this one and this one. Okay, this one and this one. It look complex, but later I show you one tutorial question, then you see very easy. Not as hard as you think. Okay. This M and this M is actually two free body diagram. One is free body diagram, one is another free body diagram. I show you one example. This one I skip for the moment for the this one is still F equal to MA diagram. If you can see it, F equal to MA. Left hand side is free body diagram. You just copy all the forces acting on the object. Right hand side is still kinematic diagram, telling you where is the direction of acceleration multiplied by the mass from the center of gravity. This one will generate one moment diagram, all the moment in this side equal to the all moment in this side. This one you're able to calculate moment at point A, right? Force multiplied by this distance is moment. Equal to all the external force combined that generate moment. Yeah. So I'll show you one example. Still the same. Just now is the straight line. This one is a curvature line. I won't go deep into detail, but I want you to see this slide as F equal to MA diagram. Left hand side is all the forces. Right hand side is the kinematic diagram, acceleration and mass effect. The purpose of drawing this diagram is to find the moment. Moment on the left will equal to moment to the right. The purpose of showing you this one. Okay. And you only need to use, if you see curvature motion, you only need to use F equal to MA in normal direction, F equal to moment, F equal to MA in normal direction, F equal to MA in tangent direction, then equilibrium of moment will be 0. If it is a curvature rotation. Then you see the rectilinear one also same. Rectilinear one in the straight line also same. You use F equal to MA, split into X and Y. You solve X direction, Y direction. Plus one more is all the moment in central of 0. Okay. After all the slides that look complicated, actually, if you look at this diagram, you already seen this one in chapter 2. You already seen this one in chapter 2. where you solve all the external force equal to ma. Now, when you come to chapter 6, you add one more diagram, which is only look at the center of gravity. Where is the direction of the center of gravity moving? Either move up, move down. You draw the direction. In this case, center of gravity, if this boat pushing to the right, the magnitude of force is ma, mass multiplied by acceleration at the center of gravity is in this direction. So this is free body diagram. This is kinematic diagram. To solve this problem, you use F equal to ma in x direction, in y direction, plus all the moment in center of gravity equals 0. You solve the question in this way. Huh? I show you in a quick way. Okay. You're quite familiar with this setting. You have a car. What is different from chapter 2? Chapter 2 question, you don't see capital G alphabet in the question. Remember that? Huh? In chapter 2 question, you don't see capital G or center of mass in the diagram. So when it comes to chapter 6, you are seeing capital G because it asks you to focus on moment of inertia or central or inertia effect. So the center of gravity is given there so that you can calculate moment. Remember that. Car show is given you 2 megagram. Remember to change into kilogram. Center of mass G is given. Determine the acceleration if the real driving wheels are always slipping, where front wheels are free to rotate. Ignore the mass of the wheel. The coefficient of kinetic friction between the wheels and the road is given, mu k, 0.25. So if you're given the mu, you know that you need to calculate the friction. If you look at the diagram, the car is moving to the left, so friction move to the right. Huh? Okay. Front wheel free to rotate means no friction for front wheel. There's a friction for the back wheel. I give you the first solution. There are two solutions. So free body diagram. You draw the G point. Remember, this is the careless mistakes. Usually when it comes to chapter 6, you will forget this one. Remember, always there is a weight from the center of gravity pointing down straight. Huh? No matter what is a terrain, either the road got angle, no angle, G always, W always pointing down. You write arrow, point down, then write W equal mg. Copy all the dimension. The wheel got contact on the road, so each wheel have contact NA, normal contact force, NA and NB. What is the difference between chapter 2? Chapter 2 assume you only have one contact. You combine NA and B as one in chapter 2 because you view it as particles. But now you look at it as rigid body, then you cannot split. You cannot see as a one. Okay. So NAB, copy the distance. The distance is for to calculate the moment later. So there's a friction at the back. Friction is pointing to the left. YB is pointing to the left because it's always slipping. So if this wheel is rotating like this, is rotating like this, so slipping direction is, the wheel direction is pointing towards right, so friction is pointing this way. The keyword here is always slipping, and do not say that the wheel is locked. If the question say the wheel is locked, then it's pointing to the right hand side. Yeah. First solution, you solve what? Determine the acceleration if the scenario is so and so. Your first solution, you use equation of motion, F equal to ma split into x and y. Then you solve moment at the center of gravity here equals 0. You know how to calculate moment, right? When you put your hand at the capital G or center of mass here, which one, what will create what? So for the moment, anti-clockwise positive, we assume anti-clockwise positive. You put here, this one will rotate clockwise, so you get negative NA multiplied by the distance, the perpendicular distance, which is this one. There's a distance here, 1.25 multiply NA, you get 1 moment. NB also multiply 0.75, you get anti-clockwise moment, positive. FB also create moment. This one is clockwise, will be negative. FB multiply 0.3, you get 1 moment. This one, Fx, all the x in x direction positive to the right. There's only one forces to the left. So this one negative. Fb equal Fmagx. Where is the direction of this car? To the left. Okay. Fy equal to ma. Y direction, you have go up positive, na minus w plus na. What else? Okay. Equal may. Does the car fly off? No. So if the car do not accelerate up, straight away 0. So here you have 3 equations. You have 1 unknown, 2 unknown, 3 unknown. You can solve. So you substitute the value there. You get the answer. You substitute lah. M is 2,000 kilogram. Mu, in this case, you don't substitute your friction first. You don't substitute friction first because sometimes you don't need to substitute. In this case, you'll find your NA and B. And then one more, I think your NA and B. Okay, so this is the first solution. By using equation of motion, F equal to ma and mg equal 0. Second solution, you are using diagram to help you. You need to draw another diagram for second method. It is using moment method. You just copy the object, put in the center of mass, put in the kinetic diagram. So actually, I already flipped the sequence. This one you already have equal to kinetic diagram. Remember? So this is to solve for moment. Second method is moment. Again, what is this different from chapter 2? Chapter 2, you don't care what is the distance of center of mass. You don't care the 0.3 distance. Okay. So you have there, and in this case, we focus on point A. Okay. If the moment equation apply about point A, then the unknown NA will be eliminated in the equation. So you look at moment at point A here, moment at point A here. Then you write this equation. This is the second solution. Second solution. The first one we use equation of equilibrium. Second equation is use this moment equation. Okay, MA equal to MKA. You write, you write sum of MA equal to sum of M, capital M, but in the italic form, K bracket A. This is to tell you that this is actually referring to the one of the diagram. So if I show you the working, you should able to see. Okay, this side I refer to this diagram. This side, this is from your free body diagram. This is free body diagram. So how you find moment at A here? You put your finger here, and A you don't need to find. You W clockwise, NB anti-clockwise, FB 0 because it's the same level, D 0. So you only need to find these two. So here NB 2 meter positive because it's anti-clockwise. NB anti-clockwise. W it should be clockwise, so this one should be negative. Typo error in my slides. Typo error. Because if you put your hand here, W is clockwise. It should be negative, not positive. Typo error. And equal to mg. How do you get moment in this case? You put your finger here. Ma is a force. This arrow multiplied by 0.3, you get moment in anti-clockwise. So positive. You write mag bracket 0.3. This moment must same as this moment. Means all the moment in this free body diagram at point A will be the same as all the moment created by MA, G referring to G point here. Yeah, free body diagram, kinematic diagram. Okay. Chapter 2, you don't write MAG. Chapter 2, you only write AG or A direction in the diagram. But when it comes to chapter 6, you need to write MA in the diagram. Okay, this is the difference between chapter 6. You put in the value and you put in another method lah. You put in the fx equals 0, fx equal to max. You manage to find. So this one, fx equal to max in the central of gravity point. Fx, you only have one forces which is negative fb. Wrong, there is no 0.3 here. There's no 0.3 here. Typo error. Typo error. No 0.3 here. Equal MA. You'll get your AG equal to 1.9 to the left. There are two methods. There are two methods. So first method, this is the second method by using moment of free body diagram and kinematic diagram. This is the second method. You see the first method. First method only using free body diagram and motion of equation, only free body diagram without touching the MA diagram. There are two methods. Two methods. Okay. So how do you know the question asks you to about using this diagram? How you know the question force you to use this diagram? This equation. You will see the question asks you solve using moment equation. Solve the question using moment equation, meaning you need to use all the moment in one point equal to all the moment in one reference point. You need to use this one. If the question mentioned, use moment equation in your solution. Then you need to draw these two diagrams, free body diagram and kinematic diagram. Okay, any question? Yeah. So yeah, basically, if you see the previous slides about this moment derivation, actually, it's just a theory part I won't ask you. Important part is what I show on the example 5, this equation, how you apply this equation by using free body diagram and kinematic diagram. Although the process behind it is very lengthy, I skip the part. If you have time, go and read the slides. Important is you know what equation to apply to solve the question. That is more important. Okay. Okay, this one is just a correction. Just a correction. Okay, example 6. Also one of my favorite question. This is a question where it's a dynamic question where the motor rider do wheelie action. Wheelie action means the front wheel leave the ground while the back of the wheel do the action. Okay, so you are giving the G point for two objects. G1 refer to motor, G2 refer to the rider. So this is a composite question. He asks you the effect of two bodies, what happens if the rider do some action. Okay, you are having point A, point B, and all the parameters are given. All right, so you're given the mass of the rider, the mass of the motor, center of mass is G1, G2. You need to determine minimum friction coefficient static between the wheel and pavement in order the rider to do this action. So in this question, don't straight away find the mu. Write friction force in your free body diagram. Write F friction, then only later you convert F friction equal to mu n. If you straight away write mu n, you will confuse yourself. Because you mu n, you have one unknown already, two unknown. One is mu, one is normal force. So you don't want to add one more unknown in the equation. What acceleration is necessary to do this one? This one actually force you to find acceleration, which is required you to use F equal to ma already. F equal to ma is a compulsory for this question. And you are seeing all these dimension means you need to use the moment approach already. Ignore the mass of the wheel and assume front wheel is free to roll. Free to roll. Free to roll means no friction for the front wheel. Okay, so you see the concept. I give you the free body diagram. So first step for chapter 6, always look at the capital G, center of mass, and then draw your W first. Okay, because this will be always the careless mistakes when it comes to test 2 or final exam. When it comes to chapter 6 kind of question, you will forget W. All right, so go to the capital G, write W1, W2, point down, and then remember contact force, NA and B, before you do the wheelie. After you do the wheelie, NA will be 0. Friction force. Okay. Again, why friction force is pointing to the right? Because the wheel action, the wheel is doing clockwise direction. Clockwise direction. So the wheel is going to the left. So your friction, your wheel is like this. Wheel like this. Okay. What else? So I just label there NA near to 0 when you do the wheelie action. Okay. So you do the kinematic diagram. Do you know how to draw the kinetic diagram? Since you are given the G1, G2, go to the G1, G2, write MA. MA G1, MA G2. Then the distance all copy lah. All the dimension you copy. Chapter 6 only interested in MA. So MAG1, MAG2. So actually there's a typo error here. I should put 1 here. I should put G2 here. Because acceleration for this G1, G2 actually it's the same lah. It's the same. Because it's at the same object. So when you're sitting at the same object, acceleration will be the same. So you can write AG sub 1, AG sub 2. Then you write AG sub 1 equal to AG sub 2 equal to AG if you want. Okay. Okay. Then we focus on, we pick B as our interest point. Why? Because we don't want to solve this one. You can put A, but A leave already, so it's very complicated case. So we look at B point to solve for the moment equation. Okay. So we pick B as our interest point. You use equation of motion, F equal to ma, F this side, all the x equal to x direction of max. All the force in y direction equal to may in y direction. Okay. And one more. You use moment equation to solve for another unknown. Because these two only solve 2 unknown, you need 3 unknown. You need 3 equations to solve 3 unknown. So all the moment in free body diagram will equal to all the moment in kinematic diagram. In this case, we refer to B. So in this case, if this kind of question come out, remember to label carefully where do you refer to. So for example, this one, you look at moment B, so write moment B. So the rest is just substitute. I just show you the detailed calculation. So you'll see 3 equations. Fx, so in this case, there's only one component that's in x, which is your Fb, friction force from the wheel, equal to ma. In this case, both have the same acceleration. So actually, this one got 2 lah. M1ag plus M2ag. But because of ag same, you can combine them together, factor out the ag. So initially, you can write in 2 components here, but because of the ag is the same, because they are sitting together, acceleration same, you only combine the mass. Y component, you look at the free body diagram, they are 1, 2, 3, 4 forces there, Na near to 0 during the wheel off. So you only have Nb, W1, W2. There's no acceleration in y direction. Okay, so here you don't draw any y direction, so equals 0. What about moment? Moment at point B, you put your hand here. So W1 generate clockwise direction, W2 generate clockwise direction. Na, you don't have Na. So you have W1 multiplied by the distance, 0.8, 0.4, equal moment in B here, kinetic diagram. So you have 2 moments. One is G1, one is G2. I think I didn't show you the another one. Okay, got 2 moment from the kinetic diagram. So this one anti-clockwise, clockwise. This one also clockwise, but you put anti-clockwise as positive. That's why negative, negative. Which one? This one. Oh, this one. Oh, this one. This one. This one should be negative. Should be negative. Huh? Yeah, typo error. W point down. Huh? Again? FB should be positive. Should be positive. FB should be positive. If I refer to the free body diagram. Okay. Okay. Now what happens if you draw the wrong direction of FB? You just follow along. If you refer to this one, then my negative is wrong. So this one should be positive. Right? Then you calculate, you get negative, then you flip the direction of the FB. Okay. So some typo error in my slides, huh? Okay. Sorting, you'll get these three answers. So AG equal to 8 point something, NB equal to 1.9 kilonewton, FB equal to 1.7 kilonewton. Remember the unit. Remember to put in a unit, and direction, don't need direction. I only see your free body diagram. If it's positive value, I will just go to your free body diagram and check. Okay. So then only you go and find the friction force. Then only you find the friction coefficient. FB equal to mu n. So from there, mu n equal to 0.9. Okay. Okay, example 7, go and see your homework. Then we continue 6.4 next week. Yes. Okay, sign your attendance. Your attendance sheet, remember to sign. Yeah.